Good morning everyone and welcome back to my channel. Today we will see how to obtain this kind of flat surface that becomes like an hexagonal pattern. That is driven by this Grasshopper and this point attractor. This is not a basic tutorial, so it's an advanced tutorial, and it's better if you follow first this other video. But we will start from the beginning, so we start from zero, and let me show the definition. First of all, we create a boundary curve. We create a flattened surface to fill this curve. Now we are going to subdivide this surface into a grid of points. Then we are going to create duplicate an offset of the surface, the first surface. So this is the offset, this is the basic surface. And on this offset surface we are going to create an hexagonal grid using LunchBox tool. LunchBox is a free tool from Food for Rhino. It's a plugin for Grasshopper, and we set division 12 division both in U and V. Now we are going to pull the basic points in the direction of the cells. So we connect the point P output of S divide into P of pull point, and then we use the output cells to enter into geometry of pull. This is the result. Okay, now we have the pulled point here and the basic point here. We create a vector that goes from the basic point to the pulled point. And we use the component vector 2-point to do this. Now we only want the direction of this vector, and we take the vector and we create a unit vector. And now we will work to define the amplitude. So we start from distance output of pull point, and we are going to divide this distance 100. We divide 100 by the distance between the pull point and the start point, and the results we multiply for an amplifier here of 100. This will be the result of this last multiplication, will be our amplitude of the final vector, and then we use this vector to move the basic points of the grid. So this is what we obtain, and basically this is a normal hexagonal pattern on a surface. Now we have we work on the points we obtain now. We are going to deconstruct these points. So we take the output of move G and we put inside this deconstruct point. Okay, we maintain the X and Y, so then we use a construct point, and we are going to work a lot inside the Z. Okay, we have to come a little back. All we will do now is in order to understand how to put inside Z, what to put inside Z. how to enter inside this construct point. Okay, now we go back and we create an attractor point, that is the point that we focused before. Then we create a line between this attractor point and each point of the grid. Then we evaluate the length of each line. Then we create a boundary that encompasses all the length of the line. Then we remap this number into a target domain that is standard, so to from 0 to 1, and then we apply a graph mapper. You can see that if you continue this line, you obtain values bigger than 1, but we don't want values bigger than 1, and so I apply this part of code and I say, if it's larger than 1, if the result is true, find the index, and here it replace. What I say is, the index you find here, you have to change the value from the value of before to 1. So basically all these parts say that if the number that exits from graph mapper is bigger than 1, then you have to put 1 to change these values with 1. Only this. Okay, I have these values replaced, and now I want to amplify these values, and we go back to the zeta coming from the z coming from the construct. If this value is less than 71, and you can choose this number, it's something that you have to try. Then if it's less, then divide the list of z divide the list of that you obtain by replace list here in two parts, and these two parts depend on the pattern of z. If z is less than 71, you have the group, the list A. If z is bigger than 71, then you have the list B. So we are going to take only the true, so only the values less than 71. And so what we have to do, we take the z coming from the construct point, and we say change the z with the new z coming from dispatch, but only if the value is, this value is less than 71. And so you have the first replace. Then you replace the items that are bigger than 71. And you say, if the value is bigger than 71, then you have to put 100 as value. Basically, if this is our boundary value, if the z is bigger than this value, then replace z with 100. That is our flat z, because we offset, you remember, we offset the surface of 100. If the value is less than 71, the number are driven by this graph mapper. So you have to take values coming from this line, increased by this amount that is basically the multiplication amount, the amplifier. And so you have to use this basically these values. The results is this new list of points, in which the point next to the attractor point are have variation due to have variation in the z direction. You can see that if we see the surface, we have that more the point is next to the attractor point, more the z direction is bigger, and it is driven by this graph mapper here. So, hope you enjoyed the video. Have a nice day and a great work.